Hey, welcome back. This is another video on the Deckel FP1 milling machine. Since the last video, I added a digital readout, linear scales, and I put the machine on proper feet. And also I wanted to address some questions or comments that I got under my last video. So one person mentioned that it seems that I'm awfully familiar with the machine. Yeah, of course, Deckel FP series milling machines are super common here in Germany. And during my entire apprenticeship and my professional time at work after apprenticeship, I always had FP1 or FP2 milling machines at my disposal. We had all FP2 and one FP3 mills in the apprentice shop. The first prototype shop that I was in had a FP1, FP2 and a FP2 NC. And where I'm now in the special machine building department, we have two FP2 machines at our disposal. The FP2 is just a little bit stouter machine, larger travels, and the horizontal spindle has a quill, which is really cool. I think it has even like 120 millimeters of quill travel, means you can push the machine into the role of a horizontal borer if you need to. And we do that from time to time if we have large parts that need side holes drilled. So that's the reason why I'm rather familiar with the machines and its possibilities. So one very common comment was the tapping. If I'm going to either change out the motor or add a VFT to add tapping capability to the machine. I'm not going to do either one of them because the machine has already a 3-phase motor and those can run in both directions by just changing two of the power wires, L1 against L2 or L1 against L3 or 2 against 3. Then the motor will just reverse its direction. That's way easier to handle than adding a VFD to an existing machine. On a proper VFD installation, you cannot have any switching elements between the VFD and the motor. Some VFDs will either burn up, explode, or in the best case just fault out if you disconnect the motor while it's running from the VFD. You have to rewire all the switches to be digital signals for the VFD, so you get a 24-volt signal to the digital input on the VFD. I'm not going to do that, that's a whole lot of work. You have to redo the whole electric cabinet. I'm just going to add a foot switch to the machine, like a pedal that will reverse the spindle on a press of the foot, which we have that at work on our drill presses, and it makes tapping a breeze. And this will be done here too. So another mention was a crane. That's coming too. While the head is fairly easy for me to lift and to put on the machine because I'm stupid tall, but the indexing head and the tables, those are bare to lift. The indexing head is like 40 kilograms and it's awkwardly low. So I got a C rail, which is usually used for barn doors. They have a load capacity of something in the realm of 150 kilograms per truck that runs in the C rail. And I will just put one piece of rail above the machine so I can pick for example the head or the indexing head off the machine, move it out, put it on a cart and get it out of the way and move the table in if I need to. And with a chain hoist obviously, or a small electrical hoist. But I don't like the small electrical hoists, the cheap ones, because they are not very precise in their movement. So chain hoist it is. So that's that. Then I got a digital readout for the machine. I bought the digital readout directly in China from Icron, up there, Icron. I ordered a digital readout, 3-axis and 3 glass scales, linear scales, 1 micron resolution, 320 millimeters, 370 for the z-axis and 170 for the y-axis. So let's look at the linear scale installation and some things I took into consideration. I didn't film the installation because it's a whole lot of cussing and drilling holes with a cordless drill. So that's not too much of a video. So the y-axis is the simplest of all of them. The linear scale is mounted up against the y-axis ram, the traveling part. And the reed head is bolted against the machine. I used the delivered hardware to mount the reed head because in this case it was the right dimension and fitted. And I also mounted the cover over the linear scale. This is just an aluminum cover. The scale is below this. I still have plenty of room to operate the y-axis handle, which is funny enough, when you stand in front of the machine up on the operating side, which is opposing to this side, you just reach over the back of the machine and tighten this lever. This is still very fine and very operational. I'm absolutely 100% okay with it. It's a fine solution that I can live with. So that's the y-axis, and then I just routed the cable with a zip tie out to the back. Not winning any cable management prizes on this machine. So down here we have the x-axis scale. This is the scale without the aluminum cover that you saw on the y-axis. It's bolted up against the saddle or the apron of the x-axis. 2 screws. Yeah, I drilled into the machine. And then I machined a block that fits the angle, the slope on this housing that is for the z-axis screw and the bevel gear that goes out to the side. So when you move the x-axis, reed head is stationary and the scale is moving along it. And then I just drilled on an angle into this casting, and the aluminum mount here is bolted against the housing, and then the reed head is bolted into this bracket from the front with 2 and 3 screws. The important thing on a Deckel toolroom mill or any of the European style toolroom mills is that the linear scales are not protruding above this surface here. The surface here is your vertical table. You cannot have anything stick up above the table because, well, in this case I have the indexing head. It's hanging over a little bit over the edge. Or if you mount, for example, a large plate or a casting directly against this table to machine it, anything that sticks up will be constantly in your way and annoy you to death. We have machines at work where the x-axis scale is mounted up against the apron, and it's not good. Don't do that. So this was already rather annoying to mount, but still fine. A little bit of machining on an angle, but the z-axis is probably the hardest on this machine. Yeah, here is my great cable routing to the back. Master of zip ties here. So I have the linear scale mounted against the column of the machine. It's bolted in with 2 screws again, with the lip seals pointing towards the back. Means I have this weird bracket here that reaches from the z-axis saddle out here. It clears these dogs here. These are the trip dogs for the power feed, so the power feed stops when you run the machine into its extreme end of the travel. And then it reaches around and goes to the reed head back here. Now this allows me to have the z-axis scale very protected against chips and probably coolant. Speaking of coolant, I decided to not run the machine with coolant because, let's have a look down here. This is the foot of the machine, and this is just a piece of sheet metal that's sitting here. And this is the pickup for the coolant. It sits in this cast tank here. And as you can see, I get all the oil from the saddle lubrication. The saddle is lubricated via a reservoir. You fill it up with oil, and then there are oil wicks that distribute the oil to all the sliding surfaces and so on. And eventually all the oil will make it into the coolant sump. And anybody who had to do with coolant in a machine knows that this is a problem. This will form a sealed layer on top of your coolant, and the coolant below the oil will start to get rancid. All sorts of life forms will start to exist in there, and I don't want the blob to be living in here. So I'm either filling the machine with cutting oil, which is a whole other sort of mess. I know people who run white oil, mineral oil in their FP1, and that's a nice solution. It also gets mixed with the sump oil in here, but well, it's oil and oil, so it doesn't get bad or go bad. But coolant and oil is always a problem. You would need either a skimmer to pull off the oil from the top, or you add a aquarium bubbler, a small diaphragm pump which constantly puts air through the coolant, and this prevents microorganisms to grow in the coolant. If you ever had to change out coolant that has gone bad, you know how ugly that can get. So no coolant for now. Just wipe it down. So no coolant for now, just oil sump. The machine came fitting on 100mm square wooden boards or wooden blocks, so you can't pallet jack it around. And I like the height of the machine, so when I got proper machine feet for it, I added a 60mm riser in combination with the adjustment nut and the foot. I think I'm 110mm away from the ground now. And this is a good height. I can operate the machine sitting or standing, which is very nice. Sometimes when you work on very small parts, it's nice to be able to sit down, steady your hands against the machine and work like that, or work up standing. It's just nice. M60 leveling bolts. The machine is now leveled and sitting in position. After a few days I will check the level and play with the bolts again. And back there is the electrical cabinet. I will hate myself when I need to do work on it, but for now it's just out of the way and not concerning me. That's a problem for future Stefan, not current Stefan. It's time to have a look at the slotting head or shaping head. I had it on the machine, I test run it, but I noticed that it's really dirty, and I'm not confident of running it over an extended period of time without having a look into it. So I brought this over, and we're most likely first going to pull off these 4 screws here so we can take this ram adapter off the actual slotting head. So let's get it vertically. Here you can see the drivetrain. This is the gear that intersects with the gear on the horizontal spindle of the FP1, and this is driving the ram in and out. Oh, interesting. That's not a screw. That's a hollow nut. That's a nut with an internal hex. Okay, these are the 4 nuts. Now we should be able to pull this off. Or maybe I should take a look into the drawing first. I went on the internet and I had a look, and I found a manual that explains how to take it apart. And first of all, you set the stroke to 0 for whatever reason. And then you loosen the stroke adjuster screw in front here. Like this, and then you should be able to pull it off. And that's a whole lot of things more than I expected, to be honest. And one of the screws fell in there. So Normally the heads have a T-nut running in the slot and a screw. And this head here appears to be using a T-slot screw and a nut with an internal hex, which is kind of an interesting solution. This is the slotting head itself with the ram, and it looks really, really good when I look in there. And we have the yoke with the stone here and the screw, which intersects in this adjuster. This thing here is adjustable for the stroke. Moves in and out, and to be honest, looking at it, I'm not going to take it apart very far because wow, this looks really, really good. I know that there is a planetary gear in there, or a internal gear more, not a planetary. I'm not too keen on taking all of this apart. I was expecting it to look awful on the inside and the waist to be like threaded up. I might pull the ram here. I'm surprised to see a gib made of brass or bronze. Didn't expect that. But I would like to clean up the ram. This whole thing looks like it was sitting in the corner of a shop, never be used, and just getting dirty, which is nice. That means that this thing is in excellent condition. Probably. Most likely. Maybe. Let's see how we can get the ram out of there. So, first we remove these cover plates. They are slotted head screws, so I'm really bearing down on the screwdriver, and I choose a screwdriver that's very exactly fitting because I don't want to strip out the screws or the slots in the screws. That looks super amateur. The first plate doesn't come off yet because the small scale that shows the stroke is still screwed on. First plate is off. It was just stuck by the oil a little bit. Okay, removing the scale, different screwdriver, smaller screw. And with the scale removed, I can also pull off the cover plate. Loosening those set screws, these hold or secure the set screws that press the gib against the ram. Backing off the gib screws, somebody painted over them. With this design you cannot slide out the gib. The gib is held in place with 2 dowel pins. Removing this top cover, this has a felt liner in it to first of all be a wiper to pull off any dirt off the ram before it goes into the slideway, and also it is an oil reservoir and helps the lubrication. The cover comes up pretty hard because there is sealing paper in it that got stuck to the other part very, very firmly. So the ram can be moved by hand now very easily, but it doesn't come out because the connection rod is still in there. So I need to find out how to remove the crank pin. Removing the circ fitting that's for lubricating the slotting head. By the way, the entire slotting head is oiled. It doesn't get any grease on it for lubrication. That's important. So a quick research on the internet told me that after you remove the lubrication fitting in front of the ram, you take a copper drift and you can hammer the crank pin out to the back. It's a decent press fit, but it's, as you saw, that was maybe a 6mm piece of round copper. And there is the connection rod with the pin. Now we can finally pull the ram. The screws that have been painted over, I want to remove the paint, of course. I put them in some acetone in a petri dish and just wait for the paint to loosen up, and then I will use gloves, tweezers and a wire brush to remove the remaining paint from these screws. Looks super amateur-like when you have over-painted screws or set screws on a machine. For the remainder of the machine, I'm using this stuff, Grand Clean Plus Flex Cleaner. I think this is rebranded BioCircle, as far as I can tell. It's since I don't use brake cleaner in the shop because I don't like it. I dislike the smell. I like how it behaves. And it's expensive. Well, this stuff is expensive too. And yeah, I just don't like it. This is a watery cleaner. It's fancy dish soap, but it works extremely well and doesn't attack most machine paints. As far as I can tell, this shaping or slotting head was never really used. Maybe for a few hours, but it's basically new. The scraping in here is in absolute perfect condition. The sliding surface here is in perfect condition apart from one or two spots, in fact, where we have a storage damage, and I will zoom in a second and you will see what I mean. Nothing is beat up, nothing is damaged. There are no wear marks on the sliding surfaces. The gib looks in perfect condition. The mechanics, the gearing here feels silk smooth. If I had to guess, because it's painted over, somebody purchased the FP1 mill with the complete accessory cabinet in gray. And at some point in time, the company that purchased this machine decided that gray is not a modern color anymore and had everything repainted. Probably the mill and everything in the accessory cabinet too. And most of the time when that happens, I have seen that often in industrial environments when machines get repainted. The people who come in and do the repainting, well, they are painters, not machine builders. They paint the machine with everything. So that's the reason why screw heads and something like that is often overpainted. But in general, it's not a terrible paint job. It's just they painted over everything. So I cleaned everything, stoned all the sliding surfaces. The small parts are here for cleaning, just to get the old oil off. I'm definitely not going to take apart the final drive here. It feels very good. There is literally close to no backlash. Feels silk smooth. Not going to touch it. I just wanted to have this apart because I wasn't sure if there is any seizing on the ways or something like that. But that was that concern wasn't a real issue. So here's the crank. So the crank has a needle bearing up here where it rides on the crank pin, and the lower pin that runs in the ram has a bronze bushing with a spiral oil groove in there, and also oil holes in the pin. So that's done properly. You might be disappointed that I'm not going to take this apart, but what it is there is a internal gear, a gear where the teeth show to the inside, and a small pinion running on the inside, not more. And the adjustment for the crank, for the stroke, is just a screw here. That's this one here. And this is just moving in and out like this. Really no rocket science here. So I'm going to put this back together. This is the aluminum casting on top. This holds a piece of felt. I washed and cleaned and oiled the felt. Should be clean enough, or should be clean. And this is just going back on top. Also the scale that shows the stroke cleaned up extremely nice. Interestingly enough, the gib is made out of brass. I'm really curious. Either Deckel did brass gibs at some point on the slotting head, or this is an extremely clean rebuild and the rebuilder chose to use a brass gib. But to be honest, it doesn't look like a rebuild. It's all just when you get a rebuilt machine, usually you can't tell it's rebuilt. It's just little things, but this doesn't feel like a rebuild. It's almost like this thing is like it came from the factory, never used. So, and here is the damage I was talking of. At first I was thinking that the ram is broken in two spots and welded back together, but it isn't. What this is this line here describes the point where the ram was sticking out the slotting head, and over the years crud and gunk and coolant and water was collecting on this line, and that created a rust line and has eaten away material. This is not just discoloration, this is material missing. And at some point in time somebody moved the ram and the same thing happened here again. Thank you. I stoned it, cleaned it up as good as possible. It's all the way around, it's here too, of course. Shouldn't be a major problem. I will have an eye on it, make sure there is no dirt moving inside the ram and creating a real problem on this in these two spots. But yeah, that's annoying. But that's used machine. That's used machine risk. It's not terrible. Could be worse. Could be a large chunk of seized material on the waste too. So that's fine. While we're here, we can look at the gorgeous grinding on the surface here. It's really excellent condition. If we don't look at this. Same out here. We have all the oil channels properly done in a zigzag, no straight lines. Hey Schablin. No straight lines, because that will create a wear mark or a non-wear mark that can interfere with the way where the oil groove stops. And the slotting head itself has some gorgeous scraping in here. Completely mint condition. This is an odd thing to see. These slotting heads often, when you see them disassembled, are beaten to hell, and this one really is not. It's good. I'm very pleased to see that. So after inspecting everything, giving a wipe down, and it's time to reassemble the slotting head. The gib, final cleaning, goes back in place. It's aligned with two dowel pins so it doesn't slide in an axial direction. Between the set screws that adjust the side play of the gib and the gib itself are pusher pieces that have the angle of the gib cut onto their end. That's a very neat solution and way better than pointy set screws against the gib. Adding the set screws. As I said, these press against the pusher pieces and the pusher pieces press against the gib. This makes adjusting the gib way nicer. Next are the set screws that lock the adjuster set screws for the gib in place. These were later only tightened very, very lightly. You don't want to squish the thread of the adjuster set screws with those. Before we put the ram in, we add a little bit of oil just so we don't do a dry assembly. And inserting the ram, that's why we let the set screws for the gib adjustment relatively loose, otherwise this is a bear to get in. And a peek from the back. We add a little bit of whey oil just so we don't move it dry. Next part is the connection rod with the crank pin. This goes inside the ram. There is a bore in the ram and it gets pressed back in, or in this case hammered in with copper drift. When hammering the pin back in place, I stop every few hits and check if the connection rod is moving freely and not binding up somewhere, just to make sure that it has clearance when I hammer the pin home. You could do this in a press too, but the press fit on this pin is not crazy tight, so using copper drift works perfectly fine. And then it's time to put the ram assembly back onto the slotting head. This is kind of tricky to line up all the 4 bolts and the eccentric crank pin. And the crank pin also has a key to it, so that's need to be keyed into the other part too, and that's a lot of cussing and trying to move stuff around. But then finally you can put on the 4 hollow nuts, the internal hex nuts. These are really weird. And tighten them down and you're good to go. And then you take the whole darn thing apart again because you forgot this one single screw. This goes into the upper bore of the connection rod and screws into the eccentric pin. That thing is a bear to put back together. You have to line up the 4 bolts with the holes, and you have to line up the crank pin with the crank disc, and also there is a key in the crank pin that needs to be lined up with the crank disc, and then you have to screw it all together from the front with the screw that I showed you that I forgot. So that's annoying. But it's back together. It's all oiled up. And next I'm going to put it back on the machine and we will have it run. And then I will adjust the side play on the ram. Because right now the gib is just knocked down a little bit. Oh, and I realized that I need to remove this cover plate again, because under this cover plate there are the screws that lock the gib screws in place. But that's only 4 screws. I also took a furniture dolly and narrowed it down a little bit with the circular saw and used some scrap wood to build a dolly for the slotting head. Slotting head just sits in these 2 blocks, and back here I have two keeper plates that interface with the dovetail of the slotting head. And to get it out, just pull it forward a little bit and then you lift it, which I'm not going to do right now because it's heavy. But that will be way easier once I have a crane in place. And why do I have it on a rolling cart? Because it can go back there and out of the way. And I'm just going to put a rag over it so I don't get another situation where dirt accumulates on top of the ram and spoils the sliding surfaces again. This is probably not the permanent solution that I'm going to use, but for now it's a solution, it's out of the way, and I can continue on working. With all organization, shop organization, there is never the best solution. In fact, with all of shop work, there is not the perfect machine, there is not the perfect tool, there is not the perfect surface finish, there is not the perfect organization system, and there is not the perfect storage. So say goodbye to perfect. I mounted the slotting head back on the machine, and now it's time to set the gib right, because I just put it in there and made it very loose, so I had some chance to actually put it back together. So putting it on the machine is nice, because then it's rigidly mounted and I can yank on it and check for side play in the dovetail. I have my indicator stand set against the ram and the indicator against the housing of the slotting head. So I have the shortest possible measuring loop back against a rigid. So if you put the indicator stand, for example, here on the rotary table and measure it against the ram, you add all the other elements, for example, the y-axis ram, into the equation, and you don't want that. You want just to measure the play between those two parts. So you zero your indicator. Well, you don't need to zero it, to be honest. I barely zero dial testing curves. I just look at the movement of the needle. Then you yank on it, and that's a solid 0.09 millimeters. That's a little bit much. And the idea is we start in the center. Let's move the indicator to the center. Make sure we have some range. Then we start in the center, and we just set this screw here a little bit tighter. That's a little bit over 0.02 millimeters. Gonna leave it like that for now. Just move a little bit further down. Whoever in the world invented magnetic screwdrivers never needed to work in a machine shop, it seems. You don't want to set it to 0, otherwise there is a serious chance of galling the way. In all honesty, the way I set gibs most of the time is I screw the screw in completely, then I just back it off a little bit. That was a little bit much. And honestly, tapered gibs are nice. Tapered gibs are really nice to set, but a good and well-designed straight gib like on this head here is perfectly fine. It's just a little bit more adjustment. I wish the import machines had more straight gibs instead of tapered gibs, because it's easier to make a straight gib if you're not down to perfect precision, because you can dial it in for non-parallelism in the male part of the dovetail. Now I know that all screws are set, and now I can start to tighten these radial screws that press against the set screws to lock them. You don't really need to tighten them a lot, it's just so the screws don't move out on their own. It's, in my opinion, better than the hex nut on the outside, because when you tighten the hex nut to lock the set screw, like many lathes have this, you always move the set screw a little bit, even if you use a wrench and a screwdriver, or a wrench in combination against each other. Now I go back to both extreme ends of the ram and check if I have any signs of life left, and the answer is no. And that's to expect when you tighten the safety screws out here. That's a little bit of back and forth then. You just do what's necessary to get your gib set right. Yeah, that feels way better. That's like 10 microns. Okay. Gonna leave it like that for now. Now I will set a little bit of a larger travel and see how it behaves when I hand crank it. I set it to 40 millimeters of stroke and I'm running it at 16 strokes per minute. That right? Yeah. And I'm just listening to it and seeing how it behaves. Also, I'm going to hand crank it just a few times up and down and see how it behaves. Looking at the oil film that forms on the dovetail. So when I yank on the ram now, you will see something interesting. It moves by 10 microns, then it goes back. And I get the same in the other direction if I could exceed some force on here. And what you saw here is the oil film. That's the oil, the whey oil, 68 ISO whey oil. That's why it's moving. So I'm going to leave it like that. It's fairly tight, but if I use the shaper for a very long time with a very long stroke, I can always loosen up the gib a little bit. But I'm mostly doing very small stuff and I need a tight ram for this. Slotting tools for the slotting head. The Deckel head uses 16 by 16 millimeter square shanked tooling, and that's huge. That's about the size. This is 16 by 16. So I made this adapter out of Tulox 33, which is pre-hardened or preheat treated tool steel, which machines very nicely and grinds very nicely, and gave it a 16 by 16 millimeter shank and a slightly larger head, and you will see in a second why, with an M6 screw and an 8 millimeter precision bore here, so I can use my regular 8 millimeter shanked slotting tools. I used to use these in the quill of my Optimum milling machine, and I want to continue to use them because they work great. And now I can just put them in here, lock them with a screw. I'm not using a set screw for a reason. This is a grade 10.9 socket head cap screw, and it uses a full-size, regular-sized 5 millimeter key, so I can tighten it properly. If I use a set screw, I have to go one size lower with the hex key, and those are prone to strip. Even if you buy a hardened one, 45H set screw, this is still nicer. And this just goes in. It rests against the bottom of the board. This is 25 millimeter deep board, or reamed, with a flat hole on the ground, or flat bottom. And this will do very nicely. A 4 millimeter tool. Lock it in, and you're good to go. That's mounted in the slotting head. So you're looking onto the underside of the slotting head. If you look up here, you see a moving part that has a square broached into it. And that's, when I tighten this nut outside here, it tightens against another part that it's riding in with also a square broached into it and tightens the tool that way. or holds it that way. And now for this shoulder. The answer is very easy why I did this. This is so the shoulder rests on the underside of the ram, which is machined, and aligns my holder automatically straight. Which is very nice because I don't have to do any alignment. Now I just put one of my 8mm shank slotting tools in here. Yeah. A little bit of alignment is needed. A little bit of alignment is needed to get the cutting edge square to the travel of the machine. And this is honestly simplest to be done with a pair of parallel pliers and an indicator. No science here. Okay, that's good enough. That's within 10 microns. Well, it's probably better because the indicator doesn't show it anymore. So I have either to consider this good enough or use a more precise indicator. I'm using the indexing head on the FP1 now for quite some time with the self-centering vise on top of it or with the collets directly in the spindle and the 40 taper of the spindle. But sometimes I also need a 3-jaw chuck just to hold parts that are slightly bigger in diameter and round. And first I was thinking about making or getting a 40 taper shank for something like a 100mm 3-jaw chuck and put it directly in the spindle, but I already have this nice flange which sits on top of the spindle, and I can just pull off the self-centering vise here. It's fairly easy. You just take off the 2 jaws and you close it all the way. And then there are 4 socket head cap screws M6. I drilled and counterbored the holes in the body of the vise myself. The body is hardened, but with a carbide drill and a carbide end mill for counterboring, it wasn't a big deal. I did this still when I had the Optimum MB4. The Optimum MB4 is perfectly capable of hard drilling materials like that too. So then we can pull off our vise here. So some might recognize this chuck. I bought this years and years ago. It's sub 100 euros when I got it. I think it's 100mm body diameter. Yeah, 100mm. I reground the top of the jaws because I needed it to be able to rest parts flat on it and run true. And also took it apart and cleaned it, showed all that on video. Got a lot of flack for buying either a cheap chuck or not giving a cheap chuck enough credit or whatever people were in the mood to complain about. Also, I made this flange here so I can put it on my Vertex 150mm rotary table. I was thinking I could either drill the 4 holes of this flange into my adapter plate here, or I ditch the adapter plate and drill straight through the chuck, counterbore the holes, and then drill that hole pattern into my faceplate here. And that's most likely what I'm going to do because that spares me of another layer of inaccuracy. So let's take this apart and drill the holes through and be done. So first we remove the jaws so we can handle this a little bit better. Oh, this is super useful. Took a, I think this is 3/8 inch socket extension, welded a piece on and milled a square for my chucks on here. And this goes in a small fine tooth ratchet. And this is very nice when you have the chuck mounted, for example, directly on a table and you can't do a full rotation with a regular chuck wrench. Or you can put this in a drill chuck, in a cordless drill, to quickly change the jaws if you want to. I do that on my 5C collet chuck. So let's remove the back plate. So these are M8. And what I'm expecting down here is a lot of goo from eternity. There we go. And here's a surprise. No rust, just mild discoloration. And the usual old oil smell, but that's fine. Note that this adapter is ground. I had a good day. I even engraved it. February 2021 I surface ground this adapter. Funny. I made this long ago, but then I decided to grind it. Okay. But when you look at this chuck, we have the holes from the back, but there is nothing on the front. So yeah, we're just going to drill through. Usually you can drill through on a drill chuck, on a scroll chuck like that. If you take a look here, the scroll doesn't go very far to the outside, and that means that we have enough room to drill through there. So we're over at the drill press because it's very easy to align this piece here on the table of the drill press for drilling. For work holding we have a T-nut, a single stud, we put the drill chuck over here, add a strap clamp, heavy washer and a nut. And the stud is way too long, but whoop. This is an M8 thread on the back side of this chuck, which has a tap drill of 6.8 millimeters, which is also a very nice through hole for an M6 screw. So I'm using a 6.8 millimeter drill to pick up my location or to align the part with the drill. Okay, now we get the drill in this tapped hole, lock the quill. Now we can very nicely set this up and clamp it in position. Okay, there we go. Tighten it down. I'm not sure what's going on with this drill bit. This is an atrocity of drill bits. Yeah, in the industry we call that dull. Okay, now we can flip the whole deal around and do the front. Just align it with a drill bit. As I said, this is just a clearance hole, not a precision hole. So drill press accuracy and best practices will do just fine. I have a piloted counterbore, which is very nice for this purpose. So we basically go down the height of the head on a metric socket head cap screw. The height of the head is always the nominal diameter of the thread. So on an M6 screw, the head height is 6 millimeters. On a 3 millimeter or M3 screw, the head height is 3 millimeters. On a M12 screw, the head height is 12 millimeters. So easy, so nice. So let's go into a slower speed. Okay, there we go. First one. I'm using the drill bit to align the part because the pilot on this countersink is only 6.4 and not 6.8 millimeters. There we go. Okay, that's all the drilling and counterboring. Now we need a set of countersinks. And we chamfer both the outer edge of the counterbore and the inner edge of the through hole. And then for the outer edge. And it's that easy to convert a back mounting chuck into a front mounting chuck. No harm done to the chuck. It still has the M8 threads from the back that were originally in there to mount it from the back side against the chuck adapter, but we also have through holes for 6mm socket head cap screws to mount it on top of something. That's what we wanted. I really like this humongous drill press, at least humongous for my purposes. For other shops it's the small drill press. But one thing I dislike is this huge hole in the center of the table. I was thinking about boring out the recess either here on the drill press with boring head or putting it on the on the FP1 and put a nice large counter bore in here with the horizontal spindle and make an insert, a replaceable insert. So because for when you want to drill small stuff on here, which you totally can because this drill press goes up to 3,200 RPM, which is fairly quick for this size of machine, you always have to have a piece of aluminum or steel here on the table to support the part in the center. So that's the only gripe I have with this machine. Apart from that, it has been very good to me. I'm using dial test indicator here in the spindle to center on my faceplate. And this is dialed in pretty good. This is basically 0 in all directions. I turned it to 0 degrees, which means that all my hole patterns that I drilled so far are aligned in X and Y, as far as the hole patterns are concerned. Oh, now it's time to change to a spot drill, set up to drill the hole pattern and then tap for the chuck. So here's our spot drill, 6mm. Okay, let's see, we want a hole pattern. Down here, circular hole pattern, XY plane. 0 is on XY. We have a pitch circle diameter of 84mm. And we have 3 holes. There we go. And now we can select holes 1, 2, and 3 by moving through. And the red point here indicates our current position where we are in the space of this machine. Okay, spot drilling. Now we change to a 5mm drill. Since it's a even diameter shank, we can hold it in a collet. There we go, 5mm collet. Got all my holes drilled and tapped, got the chuck ready, and I even managed to find some 6x70mm screws despite being extremely bad assorted in those large screw sizes. I have a full assortment from M3 up to M8, but only to 40mm. Above that length I have to order them or find something that I have in storage like these. These happen to be stainless. I will get some 10.9 grade screws that I might not drop to mount it because stainless hardware is soft as cheese. And 1, 2, 3. You might notice that there is no centering feature for this chuck. And just as on my rotary table, I prefer to dial either the chuck or the work that I'm chucking on in with an indicator on a rotary table, because usually when I do parts on a rotary table, precision is kind of important. And then I want the part to be indicated, and I don't want to rely on a centering feature for the chuck. Indicating the chuck on the rotary table is fairly quick. Let's load the jaws back in here. This is number 3, 2 and 1. Okay, there we go. Okay, for indicating, we just want to very lightly tighten those 3 screws. Really, really light. We still want to be able to shift the chuck body around on the faceplate. And I'm using a rawhide mallet here. So we are raising. Oh, it would be nice if the indicator wouldn't run into the item we're indicating. And then we find the high spot, like here. And we continue. This is the low spot, 0. Oh, this is very low because we're not touching. I used to be good at indicating. Okay, here's the high spot. Okay, let's zero it out again so we get an actual reading. Okay, 0. So that's plus 10 micron. Then it drops back to 0 very slowly. Okay, that's pretty good. Now we can finally tighten it down to a defined torque. Or to a solid yoink on the hex wrench. And since this is stainless hardware, I don't want to overdo it. So. Okay, that's pretty good. That's pretty darn good. So, and this would give me, if this was a workpiece, this would give me the confidence that my runout is on this part very good. And also, when I reclamp a part with the same diameter, I could also be sure that my runout would be good. And even if I clamped something with a different diameter, wouldn't be too far off and probably good enough for most work. But still, I think this is, in the long term, this is better than a registration diameter. A last thing that I added is a chain hoist and a piece of rail up there to be able to move it back and forth and have the hook hit the machine, of course. As you can see, this is the C-rail for carrying the chain hoist. There is a stop screw on both ends so I don't run the truck out of the rail, which would be bad under load. Well, would be bad anyways. And I have a piece of C-channel, heavy C-channel, that I have welded the barn door rail to. I used the C-channel profile because the barn door rail I got from a friend, it's two shorter pieces and I wanted one long one, and the C-channel is a nice stable ground for that. Here in the center of the picture you can see the seam between those two pieces of C-rail. And here is the truck. It runs on 4 ball bearings, has a eye hook to it, and this truck, the single truck is rated to 200 kilograms. The C-rail itself, or the C-channel profile with the rail, is bolted to the ceiling with all thread, M12 all thread, and it's screwed through the ceiling, and there is a large stiffener plate on top of the floor on the other side with the all thread going through it. So I have a very large area of where I spread out the load. So that's a very solid solution. And currently I have a ratcheting chain hoist on there. This is not going to stay because this is fairly inconvenient with the ratcheting handle up there. I am going to get one with a drive chain. So, and for example, to change out the head on the mill, all I have to do now is take a short sling, a load sling. This is rated 1,000 kilograms, way overkill for this purpose. But since I don't have anything else, that's what I'm using. Could be a tiny bit longer, to be honest. So that's going in here. Chain hoist comes over. I can hook it, pull it tight. Get those 2 locking screws undone. Get some pull on here. Oh, that's a little bit much. There we go. Now it's out of the engagement of the dovetail. And I can just move it out of range of the machine and drop it onto a cart to get out of the way. And as you can see, this head is very well balanced if you put a sling right in the spot here. So that's working out perfectly fine. And to get it back on the machine, it's basically the same. Get it into the dovetail, drop it on here. Push it back onto the drive gear back here, make sure it's meshing. And lock it. Get the chain off. And the sling. Hook goes out of the way and we can operate the mill as usual. And we don't have to take the chain hoist off the ceiling. I can move mildly behind the center of mass on the mill head with the chain hoist, so that's perfectly fine. The heads are not a real big problem, especially the vertical milling head here. This is not very heavy, but it's very convenient not to have it to lift. The slotting head is way heavier, and from there on it's only heavier heads. No, not a lighter one. The only thing that's lighter is the overarm support for horizontal milling. So let's change the indexing head against the rigid table. I never had the rigid table on this machine since I got it. It was only on the machine when it arrived on the truck, but I removed the rigid table when I pulled the machine in here because it didn't fit through the door. So let's see how we can rig this up to the hoist and move it. I have never lifted one of these with a crane. So sling goes through there to the back. Up here through this hole in the casting. So this will very likely not be balanced on the crane. Let's undo these screws. Okay, it's hanging only on one screw and the lifting sling here, so let's see what happens. Okay, that's not too bad. That's very controllable. And I think I can get it back on the same way. Just move it up here. And get it back in the T-slot. Press it up against the machine and get one bolt engaged, and then we're golden. Okay, that's not terrible. That's doable. Okay, let's get it off the machine and put the rigid table on here. Later I found out that lifting the indexing head with a long piece of all thread through the spindle of the indexing head balances it very well. So that's probably the correct way to do it. And that's the mill without anything on the vertical table or the apron, depends on who you talk to. And this would either be good to mount something very large against it, or a very long workpiece that we want to work with the vertical spindle on, or to bolt the regular rigid 90-degree table on it, which we're going to do now because without having to lift it, that's a breeze, I hope. This is not the recommended way to lift something like this with one IO bolt off the T-slot, but the table is 30 kilograms, and 30 kilograms off one T-bolt, yeah, that's not going to damage anything. If you tighten a M8 screw fully, that's several hundreds of newtons, thousands of newtons of force pulling on a T-slot. So don't even try to say that it's damaging the T-slot. So on the rigid table you need to remove the nuts of two of the bolts, and there are only holes, no sideways slots in the table. So you need to line it up and move it in. Just like this. That's it. That's it. Get it half decent centered on the machine. Get a washer and a nut on there. Okay, and that's the first time this mill sees its rigid table. Yeah. I haven't even cleaned it so far because I haven't used it yet. That's something we could do. That's the Moore rotary table. on the Deckel FP1 on the rigid table, and this would not really be possible without the crane. I could lift it on here, but it's really a bear to get it up here. Moore delivers the rotary table with a very handy handle to lift it, but this is more kind of a practical joke. It's very deceiving. It looks like you can lift it, but this thing is made out of a lot of gravity. So you can lift it, but you shouldn't. Maybe with 2 persons it's a little bit more reasonable, but not really. Don't. If you have the choice. So yeah, this is a good size. Originally Deckel made a rotary table pretty much the same size as the Moore one. The Deckel one is not as tall, and the accuracy rating on the Moore rotary table is way higher. The Deckel one is plus minus 90 arc seconds accuracy, and this one is plus minus 6 arc seconds. Some ridiculous low number at least. And it's in perfect condition. The goo you see on here on the surface of the table, this is LPS3 that has dried. That's a rust preventive. Because I use it so rarely, I keep it covered in this wax-like substance. It's a little bit like Cosmoline when it's dried, and it protects the rotary table from rust very, very well. And this rotary table literally doubles the y-axis travel of the machine. You can reach from here to here, and then you can just spin the work 180 degrees and move the other half of the part, if it's a very large part, back here, and you can do work there too. Also, if you only work with polar coordinates, this increases the accuracy of the machine too, because the polar interpolation with this rotary table is extremely accurate, and you're only relying on one additional axis for your position. So a rotary table is a good option to make a machine a little bit more precise if you need to. So let's get all this stuff back off here, get the rigid table back off. I need the indexing head to do some actual work and not just film things here on the crane. Before we leave, one last thing that I wanted to show you. This is the overarm support for the horizontal milling arbors. When you use a long milling arbor with staggered cutters on them and support them with bearing on the outward end. I got this off of eBay for very little money, literally less than $100, in very good condition. Still had the original grease on it as it seemed, even with the bearing block. I don't have the long arbors. I'm not very interested in having those. I don't expect any work that requires this, but this overarm support has a dovetail, and a dovetail is a very convenient way to mount accessories. Deckel used this overarm support to mount the milling head that's used to pick out internal corners. For example, when you have to machine a pocket with square internal corners. That's what the milling head was used for. And it's pushed onto the dovetail of the overarm support. So that's a very good mounting solution. And also you have the option to extend the Y travel of the machine this way far out. And what I want to use it for, I have this Precise Super 65. It's a milling and grinding spindle with a universal motor made by Precise. It's a 45,000 RPM spindle with something around 500 watts. And I was thinking that this might be a good fit for a high-speed solution on this machine. The original high-speed head for this mill runs only 6,000 RPM. This 45,000. So this spans away. This gives a way larger jump on the high-speed side than the high-speed head. The high-speed head was, of course, 40 taper, so very heavy duty. This is only 6mm, call it maximum. Not very heavy duty. But when you look at the work examples for these spindles, they were used for grinding, milling, and even hard milling hardened steels. And that's what I want to use it for. It can be run directly off mains power or with the original Precise Variac adjustable transformer. It has a plug outlet on the side for the spindle, a big knob here to change the RPM, and buttons to turn it on and off. It even shows the speed on here. So this is of course not the final solution to mount this spindle. This is not a solution at all. For this mock-up picture I just bolted this block with the spindle against the overall bearing here with one bolt, just to show you what it might look if I build it. And I want to build it in a way so I can not only mount it vertically, but also put it at an angle for whatever reason. Primarily for milling with extremely small cutters and for probably grinding. So yeah, that's the Super 65 spindle. The viewers from the US probably are familiar with these. I have seen them numerous times on Practical Machinist, and lathes.co.uk has a very large and very comprehensive article about those spindles and the accessories they made for them. Very interesting piece of industrial history. So that's it. That's the update on the Deckel FP1 milling machine. Thank you all for watching, and I'll be back.